Alright, y'all, this is 3.7, implicit differentiation. And the difference between implicit and explicit is that an implicit function, oops, I'm writing with white, nice. An implicit function, that y is embedded within the problem, whereas an explicit functions are solved for y. And if you want to read through all this, that's what that's saying. Up to now, all we've solved for have been explicit functions, but now we're going to look at implicit differentiation, and that's taking the derivative when the y is within your problem. It says find the derivative of the following expressions. We're going to do a few skills, and I'm going to tell you something that you didn't know what you were doing. When you say the derivative of y, that's really big. Dang it. The derivative of y with respect to x, that means you're taking the derivative of y, but your variable is x. So when you take just the derivative of x cubed, that's 3x squared dx dx. What that means is you took the derivative of x with respect to x. Now we don't write that because it cancels out. You just didn't know you were doing it. Now if you're finding over here, if you did 3y squared, really every time you're taking the derivative of y, it's still with respect to x because it's saying that this is my variable. So anytime you take the derivative of a y, you're going to put dy dx. Anytime you take the derivative of an x, if you don't have to do that because it's dx dx and it cancels out. This one is a product rule, that rule that everybody keeps forgetting to do. Anytime you have two things being multiplied together, you use the product rule. So 1 d2. Now the derivative of y is dy dx plus 2y d1. Now derivative of x is just 1. Do you have to put dx dx? No. Am I going to just right this second? Yes. That simplifies to x dy dx plus y. This one, it'd be 3x squared. I don't have to put dx dx. I'm not going to put it this time. Plus 2y. Every time I do a y, I do dy dx. When you get to the negative 3xy, we have a couple of options. You can either do negative 3 and then bracket in the xy, and then distribute the negative 3 back, or you can say the negative 3x is 1 and the y is 2. I usually just pull my 3 out and bracket it in. 1 d2 plus 2 d1. And then I distribute my 3 through. Now, you don't have to do it that way. If you want to treat the 3 as being with the x, that's fine. It'd be negative 3x dy dx minus 3y. If I distribute my 3 through. To solve the equation, x squared plus y squared equals 4 to obtain y written as an explicit function of x. The graph of this equation is a circle. What is the graph of each explicit function? That just basically means solve for y. Whoops. Darn it. I could have swore I was using a pen. X squared plus y squared equals 4. So I subtract x squared. So y squared equals 4 minus x squared. I'll take my square root. I have to remember to put my plus or minus. So I'm going to go ahead and write them separately. Equals negative. Because what happens is the positive is on the top, and then the negative gives you the bottom. Now, from here on out, the equation of a semicircle, the top right here, y equals square root of 4 minus x squared, and on the bottom, the y equals the negative square root of 4 minus x squared. AP expects you to know that. They put the equation of a semicircle on the no calculator part quite often, and you just need to know that that's the equation. The equation of a semicircle, oh my gosh, is r squared minus x squared, where r is the radius of the circle, and it's centered at 0, 0. Right here. The radius is 2 in this case because that's a 4. Now it asks me to find dy dx for the circle square x squared plus y squared equals 4. It says by differentiating the explicit functions of x. So I'm going to do, I've got y equals the square root of 4 minus x squared, and then I've got y equals the negative square root of 4 minus x squared. You should recognize this is a chain rule. I'm going to rewrite it. 4 minus x squared to the 1/2. The 4 minus x squared is my inside function. The square root is my outside function. So my derivative of the outside, leave the inside alone, times the derivative of the inside. This one will be the exact same, except for it's going to be negative. So I don't feel the need to do that again. If you feel like you want to, go ahead and see if you can get what I got. Now, by differentiating implicitly, here we go. This is where the meat of I hate it when I hit stuff with my finger. So we have the meat of the lesson. X squared plus y squared equals 4. We're going to differentiate term by term, not solving for y. So the derivative of x squared is 2x. I don't have to put dx dx. Plus 2y dy dx equals the derivative of 4 anytime the derivative of a number is 0. And I'm going to solve for dy dx because that's what I'm finding. If you go back up here, I'm solving for dy dx. So this is like my variable. So I try to get it by itself. How do I do that? Sad Mep. It's coming up on Halloween. Mep is a sad ghost. He's sad because he only has one leg. So we're going to solve for dy dx. So we're going to subtract 2x. So 2y dy, I feel sorry for him. Okay. Equals negative 2x. Again, I'm solving for dy dx. How do you get rid of multiply by some crap? I divide by that. So dy dx equals negative 2x over 2y. It says find where the derivative is positive, where it is negative, where it is 0, and where it is undefined. Okay. The derivative is positive when it's positive. So let's go back over here and look at what are we taking the derivative of. Well, the derivative was a circle. So when is the derivative positive? The derivative is positive. Let's do positive in pink. The derivative is positive where it's, that's too thick. Sorry guys. It's getting on my nerves. The derivative is positive. I will kill this thing. One more time. The derivative is positive here and here. So it's positive. It's negative, decreasing. It's 0 there, and it's undefined here, where the tangent line. Now let's see if we can figure that out from our equation. We have the derivative is negative 2x over 2y. Well, if we make it more simple, we just basically have negative x over y. Now, does it make sense that in order for the derivative to end up being positive, either x or y has to be negative? X and y must have opposite signs. So think about where they have opposite signs. Look at your quadrants. This is, in order for it to be positive, we have negative, positive, and positive, negative. Does that make sense from the equation to the graph? And oops. And then in order for it to be negative, this is for it to be positive, negative, they have to have the same sign. And if you go back over to your other one, if you look back, it was in the positive, positive quadrant and the negative, negative. That should make sense. Now, where was it 0? Here's a rule. To find where implicitly where dy dx is 0, where the top is equal to 0. dy dx is undefined where the bottom equals 0. Now that should make sense. Here's why. This is your slope of your tangent line. Alright, that's the slope of the tangent line. In order for, if you go back to the very most simple definitions of slope, you had 4 different kinds. And remember, you thought about the little man skiing. If he's skiing uphill, that's positive. Downhill is negative. Here he falls off and he dies. Okay, the slope was undefined, or no slope. And then here he's skiing with no hands, and it's 0 slope. How did you get, when you're doing just regular old slope fractions, like maybe say that's m equals up 1 over 1, down 1 over 1, how did we get a no slope here? It had to be a number over 0, and in order to give you 0, it had to be 0 over a number. So the derivative is 0 where the top is 0 here, and it's undefined where the bottom equal to 0. Because if you look at your tangent lines, bottom is 0, top is 0. There. Alright. If we have blah, 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 here's your rules. Yeah, we're just going to go right on through that. You can read that if you want to. Alright, given the curve x cubed plus y cubed equals 6xy shown to the right, you find dy dx. Okay. Take the derivative one step at a time, so it would be 3x squared plus 3y squared dy. Anytime you do a y, you have to put dy dx equals. I'm going to do it differently this time. I'm going to put my 6x as my 1 and my y as my 2. So 1 d2 plus 2 d1. If you just pull your 6 out and do a bracket, it's going to do the same thing. Now, here's the trick. I'm solving for dy dx. That is my only variable. Everything else, I just treat like as if it was a constant, just like I'm solving a regular old linear equation back in Algebra 1. How do you solve a linear equation? You get all your x's on one side, you get all your numbers on the other side, you factor, you solve. So we're going to get everything that has a dy dx in it onto the left, anything that does not have a dy dx onto the right. So I'm going to get, I'm hoping I don't do this too fast, I'm going to move this to this side, and I'm going to move my 3x squared to the other side. So I have 3y squared dy dx minus 6x dy dx equals 6y minus 3x squared. At this point, I'm going to factor my dy dx out. So dy dx comes out. I'm left with 3y squared minus 6x equals 6y minus 3x squared. I solve for dy dx. I divide by some stuff. So my dy dx, or my derivative, is that right there. It says find the equation of the tangent line and normal perpendicular line to the graph at the point 4/3, 8/3. So we'll do the tangent line over here and the normal over here. Okay, tangent line, y equals blank, x minus blank, plus blank, where my x is 4/3, my y is 8/3. Normal line, y equals blank, x minus blank, plus blank, 4/3, 8/3. And the only thing I'm missing is my slope. Well, hello. There it is. So I need to find my dy dx. So everywhere there's a y, let's see, green. Everywhere there's a y, I'm going to put 8/3. I'm going to use my calculator because I am lazy. And I'm running low on time. This video is getting really long. I apologize for that. So, let's see, 6 times y is 8/3 minus 3 times 4/3 squared over 3 times 8/3 squared minus 6 times 4/3. Let's see, view handheld only, just put it right here. Clear, no, new document. Come on, hurry up, calculator. 6 times 8/3 minus 3 times 4/3 squared. Did I do a bracket? I'll be darned, I did. Parentheses. No, I didn't. Okay, never mind. I'm dreaming. 3 times 8/3 squared minus 6 times 4/3. I see a mistake. Squared. 6 times 8/3. I don't like that it tried to square my whole thing. Hold on, I gotta fix that. Stupid calculator sometimes. Squared. Okay, check it now. 6 times 8/3 minus 3 times 4/3 squared over 3 times 8/3 squared minus 6 times 4/3. This should be a closed parentheses right there. Alright. 4/5. Awesome. Hopefully that's right. 4/5. And then my normal line is just negative 5/4. How much more of this is there? Okay, yes, don't do that. Last one. Awesome. What happened over here? My thing turned on. You don't see that, but I do. Escape. Okay, I accidentally hit a button on the side of my screen. You didn't see that because it didn't show up. Maybe it did. I have no idea. Okay, find dy dx at 0, 0 of the function tan of x plus y equals x. Tricky. Alright, derivative of tan. Chain rule. Secant squared. Leave the inside alone. Times the derivative of the inside. The derivative of the inside is, derivative of x is 1 plus dy dx equals 1. Ooh, tricky one. I'm solving for dy dx, so I have to divide this whole thing. So I got 1 plus dy dx equals 1 over secant squared of x plus y. You could have distributed and then some stuff, but this is just as easy. So dy dx equals 1 over secant squared of x plus y minus 1. 0, 0, so 1 over secant squared of 0 minus 1. Now secant is 0, 1, 0. Secant is the reciprocal of cosine. Cosine is 1, so secant squared is 1, is 1. So it's 1 over 1 minus 1, which is 0. And we're done. Yes. Okay, F10.